The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
All right. So we're taking 4th of July week off, but we're recording this before 4th of July, actually during 4th of July week, but we won't air this until after 4th of July.
Yeah.
So we discussed lying to people and pretending like we already grilled, but we decided to be honest because it's what we do.
Yeah.
You know, so
Yeah.
Steve, you got the smoker? Breaking out the smoker?
Yeah, I got the smoker ready to go. I picked up 2 racks of ribs. I went with two racks of St. Louis style ribs, and I got some Myron Mixon rib rub that Scott Tallman actually sent me.
Yeah, he sent me some
Christmas.
stuff too. It's really good.
And yeah, it's really good stuff. And then I was at Walmart and I picked up a bottle of Blues Hog raspberry chipotle barbecue sauce. And I just tried a little bit and just put it on a spoon and just tasted it, and I'm blown away. It's just amazing. And they make a bunch of different brands, a bunch of different flavors, I should say. And they have the original and they have some hot, some sweet, and I'm excited. It's going to be awesome.
When I think of barbecue sauce and grilling and smoking, Walmart's the first thing that comes to mind.
Well, naturally.
Yeah, of course.
And then I got some brats that I'm going to be grilling on the other grill, on the regular propane grill. I got some brats, and I got the cheese brats, and I got some other jalapeno brats, and then I got Chinese sausage. I don't know if you've ever had Chinese sausage from Market Basket. It's amazing. It tastes almost like the same flavor of boneless ribs that you would get from a Chinese restaurant, and it's just really, really good. Kids go nuts for it. Mm-hmm. So besides that, burgers, hot dogs, maybe some linguiça dogs, some linguiça patties, and just chilling at home with some beers, and that's it. That's my 4th.
You're doing it big.
All right, so Bryn, you got plans?
Yeah. My family is going up to the lake in New Hampshire, and my aunt, I know, got a bunch of meats, kielbasa, sausage, steaks. I'm going to do a Korean barbecue steak. So I'm going to make the barbecue sauce from scratch with some gochujang and all the traditional Korean flavors, and that'll be my contribution.
All right, good. I'm just doing, like I said before, just the steak tips, and I usually 3 different containers. I marinate in 3 different ways. One is just simply teriyaki. Another one, a little wine and garlic, sort of like Portuguese, a little hot pepper in there. And then just some Montreal seasoning, what I like. I'm going to do burgers too, but I'm going to do handmade burgers, not the frozen kind.
With egg?
No egg. In fact, last time we talked about this, we got an email. I'm going to read the email. It says, "Great podcast, but eggs for a binder, ? Hamburgers are supposed to be tender, minimally processed. When you mix the egg in it, it's not a hamburger anymore. It's a meatloaf or a meatball." And I agree with that. So I'm going to, and I think, 70-30, 75-25, because as we said before, fat equals flavor. You can't put too much stuff in it. You don't want to put salt in it because salt is going to get rid of the moisture. It's going to draw it out. Onions, Vidalia onions, finely chopped in there, mixed in. It's okay. Bacon bits, I might do some mixed in. And then you throw them on the grill. You leave the lid open. Right, you throw them on the grill on the high side. They'll get nice and hot, high heat. 2 minutes on one side, 2 minutes on the other side. You get that nice sear on there, and then you flip it every 2 minutes. Some people that say, you only flip it once. I said, no, I got to flip it every 2 minutes just to keep it going. And then depending on how you like it, I use the temperature probe for my wife because she likes it well, but she doesn't like hockey pucks.
Okay.
I like it medium. So
Yeah, true Portuguese fashion. Flip them every 2 minutes till they dry out.
just like my mother used to make. But that email was from I forgot to. I don't know if I mentioned his name, Tony Caminiti, and I hope I didn't butcher his name. But Tony, thanks for the email and keep them coming. I couldn't agree more.
And for all the diehard grill people out there, when you have your metal tongs in your hand, you got to click them twice before you start grilling.
Yeah, of course.
Right.
That's law.
That's right. And if your wife walks by with, well, never mind. I can't go.
Just like when you pick up a drill,
Yep. That's it.
you got to pull the trigger a couple times.
Yep. All right. So let's continue this discussion of the refrigerant flow. So just to review, we talked about cooling mode and the different patterns we can get in cooling mode. Mm-hmm. And we talked about the heat mode. We talked about defrost and how there's basically just one pattern in heat. We talked about defrost initiation and termination. So let's continue with the refrigerant flow. Once the refrigerant leaves the outdoor unit, Bryn, let's take the R2 system. Where's that refrigerant going to go next?
Well, with our R2 systems, it's our heat recovery, so we need a branch controller. So that's where our refrigerant's going to go with an R2 system, is the branch controller. So depending on what mode, it's going to determine what is coming out of that outdoor unit. If it's in cooling mode, we're going to have a high pressure, high temp subcooled liquid. And then if we are in heat mode, it's high pressure, high temp superheated vapor. And once we get into that branch controller, depending on what mode we're in, we hit this gas liquid separator. And depending on, if we're in a primarily heat mode, that gas liquid separator is primarily filled with a high pressure vapor. If we're in primarily cooling mode, we're going to be mostly a subcooled liquid. So when we're talking about specifically cooling mode, after the gas liquid separator, we're going to have mostly a subcooled liquid coming out. And we go through two tube-and-tube heat exchangers or subcoolers that essentially we have an LEV after those two tube-and-tube heat exchangers that's metering back through them to further subcool that liquid so that we make sure that we have an adequately subcooled liquid. It's a full column of liquid going to our indoor units. With the commercial units, our indoor units have the LEVs inside of them. So that's where the metering happens. That's our second base of the refrigerant flow. Before we get there, we actually exit our branch controller through the check valve blocks in cooling mode. Coming out of our branch controller, we go through LEV3. We've got our full column of subcooled liquid. We hit our check valve block. We exit the branch controller to our indoor unit. We meter at the indoor unit, dropping pressure, dropping temperature. We come back to the branch controller as a low pressure, low temperature, superheated vapor through our solenoid valve block. And that solenoid valve block has 3 ports. When we are in cooling mode, ports A and C are being used. So a good way to remember that is if we're in cooling mode, ports A, C are the ones being used. And then that low pressure, low temp vapor goes back outside to be recompressed.
Can we back up just a little bit?
Absolutely.
I want to make sure I understand it. And of course I do, but I want to make sure
everyone's got to
understand it. So coming into the branch box and, there's the gas liquid separator. Mm-hmm. And that's, to me, the way I always explained it in classes, I held up a water bottle.
Yep.
Right? It's got liquid and vapor in it. It does. Not like we have in refrigerant, but there's vapor in it. And if I increase the pressure, the lid is off the top of the bottle. If I increase the pressure, vapor is going to come out.
Yep.
If I flip it upside down and take off the cap, the liquid's going to come out. And that's all it does.
Yeah.
It's just a container. So let's take it. So we got the tube-and-tube heat exchangers. We have a subcooled liquid coming into them. Are we looking for a certain temperature range there, or is there a certain amount of subcooling through there?
Yeah, so typically because we have 2, we actually check on the outlet of both sides. So we check our subcooling going into our first tube-and-tube heat exchanger, and we're looking for about 5 to 27 degrees of subcooling. And then once we get through our second tube-and-tube heat exchanger, our target is typically between 18 and 54 degrees of subcooling coming out of that second tube-and-tube heat exchanger.
And we're measuring that with thermistors.
Thermistors and pressure transducers.
Pressure transducers.
Yep.
All right. And I used to ask this question. You and I think, have talked about this with basic refrigeration. And I always ask the question in class, can I have refrigeration with 0 degrees of superheat? Of course, the answer is yes.
Yep.
And I would ask, can we have refrigeration with 0 degrees of subcooling? And I'd be surprised. People are like, well, no. No, we need subcooling.
Right.
We need at least 1 degree of subcooling. So 0 subcooling, no bueno, no good.
No. Yeah, so then typically once we get to our indoor coils, what we're looking for is about a 0 to 10 superheat through that coil. Typically you'll see our targets for temperature of that coil is between 32 and 50 degrees. That gives us a good idea of how that system's performing.
right? And that was the cool mode,
Yeah.
right? Steve,
Yeah, what a lot of people don't realize is that on the city multi-site, our metering devices are at the indoor unit, not like the residential units where the metering devices live in the outdoor unit or in with the smart multi in the branch box. So this for the city multi-site, for the R2 and the Y series, our indoor units are more like a typical HVAC system where the metering device is right at the inlet of the evaporator coil.
Yep.
Steve, walk us through the heat mode. So we come out of the outdoor unit, we hit the BC controller, and we're in heat mode. So now what's happening to the refrigerant?
So if we're in 100% heat mode, then we're going in as a high temperature, high pressure superheated vapor right into the gas liquid separator. And we're coming out of the top of the gas liquid separator. So now our flow is reversed. Like Bryn said earlier, when we're in cooling, we're exiting the check valve block. When we're in heating, we're going out the top of the gas liquid separator and we're entering our solenoid valve block. And at that point, our solenoid valve block, instead of A and C solenoids being energized, now it's just the B solenoid energized by itself. And that hot gas enters our indoor units. And again, think of it reversed like a typical heat pump. And we're going to meter coming out of the indoor unit into a subcooled liquid at that point. And here's the beauty of the simultaneous heating and cooling is that if any indoor units need cooling during that heat cycle, what's the state of the refrigerant coming out of the indoor units in heat?
The subcooled liquid.
It's a subcooled liquid. So why not run it through one of our tube-and-tube heat exchangers and subcool it to target and send that to the indoor units? We didn't have to go back out to the outdoor unit to do all this work. It's all being done in the branch controller. And some people call it magic, but it's really not magic. No. It's just refrigeration, right?
It's the very definition of refrigeration. We're taking the heat from the people who don't want it, where it's not wanted, and putting it to where it is wanted. Right? And in a perfect world, in a perfect system, if we have half the capacity in cooling and half the capacity in heating, then that refrigerant never even has to go back out to the condensing unit. We can turn off the fans. We're not going to need them. And people say, well, that's theoretic. That's theoretic. But when I first started here, I saw a maintenance tool file. Joe Opie, who used to work with us, one of the smartest people I've ever met, and loves fishing, by the way, Steve. You'd like him. But he showed me a maintenance tool file, and that system was 50-50. So it's not just a theory. It actually can happen.
Yep.
Right. Yeah, we call it the unicorn, right?
Yeah.
But at that point, you may walk up to the outdoor unit and the condenser fan motors may be at very low speed or even off. Compressors just coasting along at a low frequency in that 50-50 mode. One mode is assisting the other. It's pretty cool.
Yeah. Even if it's not 50-50, it's 75-25. It's still efficient. It's still a lot more efficient than taking the heat or the cold out of the air that's outside. So.
Yeah, absolutely.
Yeah. I always tell students in class, I said, it's easy for me to stand up here and just point out the flow of refrigerant and all of this magic is happening. Well, there's a big strategy going on between LEVs communicating with thermistors and solenoid valves and the frequency of the compressor and all of these components coming together to come up with a strategy to make all of this happen and manage refrigerant properly throughout the system. So that's really important. And all of these targets can be seen on maintenance tool. All these LEV step positions can be seen on maintenance tool. And even on using live data, like we talked about countless times on past podcast episodes, using live data through SW4 dip switch bank on the outdoor unit, you can see real-time data. Yep. So it's really cool stuff.
Right. So the indoor units are typically looking for about 5 to 27 degrees of subcooling in the heat mode. And coil temperature, what are we looking for coil temperature?
130 to 155.
Yeah, that's a nice warm coil.
Yep, plenty warm enough. And then the only other thing that kind of goes on in the branch controller when we are in heat mode only, so when we're in cooling mode only, LEV4 is typically closed or at minimum position of 41 pulses. But when we are in heat mode, LEV4 acts as a liquid balance control. So LEV4 will start to meter in heat mode, and essentially any excess liquid, right? If we're primarily in heat mode, we don't need as much liquid as maybe being made by all those indoor units in heat. So that will actually flash, and it almost kind of acts like a second base right? So when we're looking at the refrigerant circuit, your typical refrigerant circuit, your metering device in heat mode is kind of like LEV4. It's going to flash back to the outdoor unit.
Yeah, that's a great explanation for LEV4. So I always get that question in class. What is that LEV doing, right? And its primary purpose is in heat mode.
And then Steve started to touch on it when we're talking about mixed modes, that when we are in mixed modes, we can take the subcooled liquid from our heating coils and we can pass it through our second tube-in-tube heat exchanger and then send that subcooled liquid into our units in cooling to cool the space. So the problem is that we can't take the superheated vapor from our cooling coils and send that to our heating coils. And I use this example in class all the time. If we have a coil that's 46 degrees and it has 10 degrees of superheat, what temperature is that refrigerant? And it's 56 degrees. Can we heat a space with 56 degree refrigerant? Of course not. Right. So then it becomes, well, what do we need to do to that refrigerant to heat it back up? We need to recompress it. Yep. So we can take the subcooled liquid from our heating coils to satisfy our cooling coils. We cannot take the superheated vapor from our cooling coils to satisfy our heating coils. We need to send it back outside and compress it again. When we compress it, we raise pressure, we raise temperature, and that's where, when we mentioned a couple podcasts ago about LEV2D, that's where it comes in. Yep. We're going to take that high pressure, high temp superheated vapor, bypass our coil because we're not doing the heat rejection outside, and bring it in as a gas liquid mixture to our branch controller. Now that same refrigerant can now be used for those heat calls.
All right. I got one for you. So that's the main BC we've been talking about now. Mm-hmm. Or if we just have one BC. What if we have a sub? What happens between the main BC and the sub BC?
So unlike the main BC, our subs do not have the gas liquid separator. So we need 3 pipes. So we have our high pressure gas, our high pressure liquid, and then our low pressure gas.
Yes, 3 pipes going from the main to the sub.
Yep.
Just to be clear. Yep.
Yep. And that allows us to still have the mixed modes. We can still have the high pressure gas for our heating calls. We can still have the subcooled liquid for our cooling calls, but they're going to come back through a common superheated, a low pressure gas for our cooling calls. We're going to go back through that low pressure gas pipe that we don't necessarily need with the high pressure gas we don't necessarily need with the main BC.
Anything else a technician needs to know about the BC controllers?
Yeah, I mean, for the most part, it's knowing what your LEV should be doing. So one thing that you can guarantee is that when we are in cooling-only cooling main, our LEV1 is always wide open, LEV4 is always at minimum position of 41, and then LEV3 is metering. And then when we switch to heat mode, LEV4 should be metering, LEV3 should be metering, and LEV1 should be metering.
Yeah, something I want to just point out as well is when we're in heating mode and we call for a unit to be in heat mode, there's something that happens to that indoor unit before it actually goes into full heating mode. It's called preheating, right? So we don't want to blow cold air into the space. So don't be surprised if when you have a call for heat on one of your indoor units, you're watching maintenance tool and you look at that indoor unit on maintenance tool and it says preheating. And it's in preheating for a few minutes, up to 5 minutes sometimes. Why is it taking so long? Well, think about it. We're trying to warm that coil up to a certain temperature before we start supplying air to that room. We don't want to supply cold air to that room. So there's a process.
Yeah, and it's all about, that one's about comfort. You don't want somebody sitting there at their office and it's wintertime and the cold air blowing on them, because you will get a call.
Yes.
Right. In previous generations, we could only put 2 sub-branch controllers on the system, a main and 2 subs. Now with the N generation, we can do up to 11 subs on that, and we can get an overall longer pipe length. And with all of this that we're talking about, it is so important that you do not exceed line lengths. Follow your installation manual. Do not exceed vertical separation between outdoor unit and branch controllers and indoor units. All of those measurements are in the installation manual, all your min and maximums, and make sure you run it through Diamond System Builder.
Yes.
Free software on mylinkdrive.com to make sure that you don't exceed that, because what can happen if we exceed line sets?
Well, you're not going to get the same refrigeration effect, that's for sure. You're probably going to have some issues with getting enough subcooled liquid to your indoor coils, and that's going to cause all kinds of issues with comfort.
You could have an issue with the oil return.
That too.
which is a
Yes.
big problem.
Yep.
And, and I hate to keep beating this dead horse, but there's a reason that we mention this on a lot of podcasts. It's because it's so important. Build the system in Diamond System Builder with estimated line lengths first before you show up. And I've said this, and some people disagree with me, but if you're going to install a city multi-system, if you're the installer and you don't have a Diamond System Builder file, either a printed version of it or the actual electronic version of it on a laptop, don't start the installation. You will fail.
Right.
I wouldn't say you will fail, but you have a higher chance of failing. Get that system in Diamond System Builder, get it built in there, guess on the lengths, guess on the heights, realistically. And then just as important is do an as-built. You're not going to know how much refrigerant to put in there unless you do the as-built. What are the actual lengths, Guess a little high. If you think it's 80 feet, make it 100 feet. And then later on, put in the actual length. If it happens to be 78 feet or 75, whatever, 82 feet, guess a little high. Because it'll tell you. If you exceed that line length, it'll tell you.
Yeah.
The one thing that drives me crazy is when I see a Diamond System Builder plan and all the lengths are 0, all the heights are 0. How am I supposed to know, if I'm going to, because you don't want to do that and then find out after you do the as-built that you've exceeded.
Right.
Because you know what? When something's installed wrong and it's already done and up and running, guess what? Most of the time, 99.9% of the time, it stays installed wrong.
Yep.
And if you exceed those lengths, nobody can tell you how much refrigerant the system's supposed to have. You're not going to get proper operation, proper efficiency, and oil return, and you could damage something, and it's on you. So please.
Yeah, and as with any Mitsubishi piece of equipment, we do not add P-traps.
Right.
There's only one circumstance on the city multi-side where we have 2 condensing units 6 or more feet apart from each other. Then there's an inverted trap that goes between those 2 outdoor units, but nowhere else on the residential or commercial side. I know myself doing a lot of supermarket refrigeration and just basic refrigeration walk-in coolers in the past, and even HVAC. There was always a rule of thumb or code that we all stuck by. Every 16 feet of rise, add a P-trap for oil return. No, these systems are engineered. If we stay within the line lengths and the restrictions and we follow the installation manual, you do not need P-traps. But sometimes we inadvertently create one. So be really careful on how you're running your piping. You got to go underneath a beam. Is there another way to run that where I'm not going to create a trap?
Yeah, we've discussed that in depth in the past too.
Yeah, and our units have oil recovery control. They have a feature built in to pull that oil back, so there's really no need for the trap. They're designed to be able to get that oil back without it.
Yep, good. And then I think the one piece we haven't talked about, what happens with the refrigerant, is at the indoor units. I mean, it's going to be quite simple. Every indoor unit is in and out.
Yep.
So let's talk about cooling mode. Any indoor unit, they're all the same, right?
Yes. Yep. So we enter in cooling mode. We enter our indoor coils at TH2, and we exit at TH3. LEV is metering anywhere from 0 to 3,000 pulses to allow more or less refrigerant through, dropping that pressure, dropping that temperature. And one thing that was actually kind of interesting to me that I found is even in heating mode, so we enter on TH3, we exit on TH2, but even in heating mode, the metering device is still going to do some metering.
Right.
And we're not necessarily, if we take a superheated vapor through an LEV, it's not necessarily going to change state. In this case, it is actually there to help slow down the flow of that refrigerant so that we can get more subcooling through that coil.
Right. In the cooling, I've always looked at it this way. In the cooling mode, it's just a metering device like you'd expect.
Yep.
But in the heating mode, it's more just a flow regulator more than anything else.
Yeah, but it does make a difference because that's how we guarantee we're coming back subcooled.
Yep.
So that about does it for in-person training. Make sure you check out MitsubishiComfort.com. Click on For Professionals, click on For Pros, and select training, and you'll see a calendar of all of our training events at our 10 training centers across the country. And for information on the R2 system or the Y Series City Multi-System, always go to mylinkdrive.com. We have our service manuals, installation manuals, data books, engineering manuals, app notes, tech tip videos, you name it. It's on the website, mylinkdrive.com.
Hey, Steve, one more thing too. On our LMS, when you sign up for classes, we have e-learning, and there's one e-learning class, Refrigeration 101, if I recall if it's the right name. But Reverend Al put that class together years ago, and we recorded him. He's retired; he's no longer with us. But that's good if you're new to the industry, new to the business, and you're not really sure. It's Refrigeration 101. That's a good class.
Yeah, we actually also have a software that you can download that breaks down the refrigerant flow of our R2 systems. It's
point.
showing a KGen, but it's a downloadable software. It's narrated by our CEO, Mark Kuntz. So it's another way to kind of get a visual aspect of what we've talked about today.
Yeah, nice animation of what happens to the refrigerant in very high level terms. Yeah.
Yeah. If you take your mouse and you hover it over each component, it'll give you a description of what the compressor is, what it does, for a very basic overview to a high level overview of how the R2 system operates.
All right.
What we just talked about.
All right, good. So that does it for this episode. So we're going to air this after the 4th of July. So how was your 4th? Did you guys have a good time?
I think I had a great time.
I think I had a good time too.
The Korean barbecue was a hit.
Boy, that weather, either rainy or hot and dry, was couldn't have been better or worse.
Yeah. Yeah, my ribs could win a competition. They were so good. Blues hog, raspberry, chipotle barbecue sauce. Oh, yeah.
Yep.
Yeah. And you brought some in for work the next Monday, so thanks for that.
Yeah, that was great.
So in all seriousness, is there anything, Bill, that you've done before on the 4th or cooked before on the 4th, out of the ordinary, unusual, anything you can think of, Paul? I know for me, it's the seafood packets, the little clam boil packets with foil that you can make. I think I'm going to try and do that again, try and keep it healthy.
I've done that, but you know what I do? Instead of wrapping it in foil, I take a cast iron skillet and I'll put it in the skillet and then wrap the skillet in foil.
Ooh.
Right?
All right.
So I've done that because I love cooking with cast iron. And it works on the grill too. Sometimes I'll cook, I don't want to think up the house with bacon. I'll bring it up on the grill. Throw the cast iron skillet in there and, cook the bacon there. But I've done that with the clams, the corn on the cob, the chorizo, and everything else. And right in the cast iron, the biggest one I got, and wrap that nice and tight, and you're good.
Scott Tallman invited me over his house when I was down in Georgia for some steaks. And he threw his cast iron grill on his green egg. And that green egg gets, I think, up to 800 degrees. It's like insane. So he had that pan smoking hot. And he threw some butter in there. I think some beef tallow that he threw in there as well, and some rosemary, some garlic.
That's interesting.
Yeah, that boy knows how to cook.
That's interesting. I've been to Atlanta several times. Not once have I been invited to his house.
Yeah, you're gonna have to get with him, Paul.
Yeah, I guess he doesn't like working here that much.
I think the weirdest thing that I've ever made on for the 4th of July was Brussels sprouts, and I know they were a hit with you guys, and they were equally a hit when I made them on the 4th.
It's a vile weed. It really is. All right, guys, I guess that's it. In all honesty, in all seriousness, enjoy the holiday, and folks, if you're out there, drive safe, and thanks for listening.